This study focused on detecting phishing emails using deep learning. The authors built a lightweight CNN model, then enhanced it with recurrent layers like LSTM and GRU. Their best version reached over 99% accuracy, proving that a smaller, well-designed model can outperform far more complex one. This article does something many other articles don't. It states its research question directly. The authors tells early on how effective deep learning models at detecting phishing emails, and specifically whether augmenting a CNN with recurrent layers leads to better accuracy. That clarity is earned, not assumed. Before the question is even posed, the authors walk us through where all the methods fall short: blacklisting, signature-based detection, and manual feature engineering. Each has its limits. By the time the research question appears, it feels justified. Look closer though, and there are really two questions here. Not one, augmentation and model depth, and that overlap makes it a little unclear which the study sees as its main contribution.
Regarding the appropriateness of methods, the researchers used suitable data pre-processing techniques, including extracting email content, removing noise, normalizing URLs, and applying borderline mode to address class imbalance. For model selection, they combine 1D CNN with BI-GRU and BI-LSTM, allowing the model to capture both textual features and contextual information. They also perform systematic hyperparameter optimization using the Talos library and evaluated performance using multiple metrics, including accuracy, precision, recall, F1 score, and ROC AUC. However, a key limitation is that the data sets were collected between 2004 and 2007, which may not fully represent modern phishing attacks.
When analyzing the validity of the author's results and its data interpretation, we can break down their approach into four key components. First, for key findings, the study highlights its top-performing BI-GRU model, achieving an impressive 99.68% accuracy and 100% precision. Second, in their result explanation, they systematically explain why competing models differ, noting dataset biases in deep anti-fishnet and header reliances in Themis. Third, regarding visual breakdown, the authors present a complete visual breakdown across all tested architecture, rather than cherry-picking, while backing their data with mean value and standard deviation from 30 test rounds. Finally, for relation to objectives, the result directly confirmed their claim on model depth, showing single-layer CNN achieved 98.87% accuracy, whereas four-layer models dropped sharply to 34.42%.
This study has several limitations. First, it relies on publicly available benchmark datasets, which may not accurately represent real-world phishing emails because phishing attacks continue to evolve. As a result, the models may perform differently when faced with new or unseen phishing techniques. The study focused mainly on prediction accuracy while providing limited discussion on practical implementation factors such as computational complexity, training time, memory usage, and scalability. It also does not explore explainable AI, which could improve user understanding of the model decisions. Future research should evaluate the models using more diverse datasets and real-world environment.
Now, I will explain the significance of the findings. Firstly, the study improves phishing email detection. It shows that deep learning models, especially the BI-GRU model, can identify phishing emails more accurately, making email security systems more effective. Secondly, it helps protect sensitive information. By detecting phishing emails early, the system can reduce the risk of data breaches and unauthorized access to personal or organizational information. Thirdly, the findings help minimize financial and reputational losses. Successful phishing attacks can lead to financial damage and loss of trust, so improving detection helps organizations avoid these consequences. In addition, the study supports the development of intelligent cybersecurity solutions. It demonstrates how AI can be applied to strengthen email security and improve protection against cyber threats. Finally, the research provides a foundation for future studies. Future researchers can build on this work by using larger datasets, hybrid models, and more advanced AI techniques to further improve phishing email detection.
From an ethical perspective, the study used publicly available datasets instead of collecting data from human participants, so ethical approval and informed consent were not required. The author also declared that they had no conflict of interest. However, some ethical concerns remain, particularly the possibility of dataset bias because only 2 benchmark datasets were used. The paper provides limited discussion on AI fairness, transparency, and responsible deployment. Future research should address this issue to ensure that phishing detection systems are reliable, fair and ethically implemented in real-world applications.
To conclude, the author's conclusions are supported by the experimental results. Among all the people tested, the bi-group variant achieved the best performance, showing that the proposed approach is effective for phishing email detection. However, the study has one important limitation. The model was evaluated using only 2 public datasets, so its performance in real-world environments still needs to be verified. Future studies should test the model using larger, more recent and more diverse datasets. Overall, our group believes that this is a credible and valuable study. It has a clear methodology, strong experimental results, and provides meaningful contributions to phishing email detection and future cybersecurity research. Thank you.